Welcome to javathreads. Run multiple tasks simultaneously. Here is what we will learn. Let's get started. Why do we need this concept? Running tasks one after another makes programs slow and unresponsive. How do we do multiple things at once? Programs wait for one task. Slow and unresponsive apps cannot use multiple CPU cores. Threads enable concurrent execution for faster, responsive applications. How is javathreads used in the real world? Web servers handle multiple client connections. Background tasks run downloads while UI stays respond. Data processing parallel calculations for faster javathreads powers all these applications. Let's see the problem it solves. So what happens without javathreads? Running tasks sequentially wastes CPU idle time. Look at how messy the code gets. CPU sits idle waiting. Tasks block each other. Poor resource utilization. There has to be a better way. Here comes the solution. javathreads. Look how clean the code is now. Parallel task execution. Better CPU utilization. Responsive applications. Compare the difference. And that is why we use javathreads. Let's see how to implement javathreads in code. Here is the implementation. Extend thread class. Create custom thread class. Override run method. Define threads task. Thread action. Print running message. Create thread. Instantiate thread object. Start thread. Begin execution. Now let's see the output of this code. Quiz time. Test your understanding. How do you create a thread in Java? Which one is correct? The correct answer is extend thread class or implement runnable interface. What does start do? Which one is correct? The correct answer is start creates new thread and calls run. What's the output? Which one is correct? The correct answer is thread scheduling is unpredictable. Which method causes thread to wait? Which one is correct? The correct answer is sleep pauses thread for specified milliseconds. Here is a challenge for you. What's printed? Comment your answer below. If you found this helpful, please like and subscribe.